Section 9.5, hypothesis test for one population. And in this case, the population standard deviation is not known. It's not known. So how do we work with this out? Do we just leave it, or what do we actually do? In this case, since the population standard deviation is not known, we will be using the sample standard deviation, which is small s instead of that sigma, small sigma. So it's a small s. But keep in mind, I want to remind you that in both this test and the z-test, this is going to be called the t-test, t-student distribution, or t-test. Both of them should be normally distributed. If both of them or neither one of them is normally distributed, then neither of the tests can be used. Neither of the tests can be used. Not normal distributed. Then neither of the tests can be used. And so what happened in this case? In this case, we use something called a non-parametric procedure. Oops. Non-parametric procedure can be used, which we don't have to worry about it that much for now. So to start with this, what is the t-test? We need to find the t-value, like the T statistic, let's call it, x bar minus mu as before. Instead of sigma, we have s over the square root of n. This is called the one mean t-test, or in summary, we just say simply t-test, the t-test. And for this t-test, we need what we call degrees of freedom, which is n minus 1, and table 4 to work things out. Table 4, which I'll show you in a minute how to use the table. So for here, what we need to start doing is start looking at some examples. Let's say I want to find, so it's asking us to find, estimate the p-value. P-value is always the area, always the area. So estimate the p-value, okay, of a left-tail test, left-tail t-test, say specified, with a sample size. So n is given to us. So n is given as 12. From here, right away, you get degrees of freedom. 12 minus 1, 11. Okay, and then they give us the test statistic. So that's like t sub 0 or t. T sub 0 or t. They give it to us, t or t sub 0, as I said. We didn't calculate it here. It's ready for us. So what we need to do here is to find the p-value, and then we can convert it to an alpha later if they want us to reject or fail to reject a null hypothesis. So what do we do? How do we find the p-value? Okay, how do you find the p-value? Now the p-value needs to be found by going to the table. And what do I have to find in the table? Well, this graph here is symmetric about the origin. So when you are dealing or looking for an area less, because left means the less, that's why they shaded the left area here. See, the area on the left was shaded. That's the same if you find it for 1.938, 1 point or a little bit here. So in this shaded region or that shaded region, they're the same. And why am I looking at the positive case? Because if you look at the table, you're not going to find the negative t values. But what we can do is, by symmetry, they are actually the same area. So we're going to look in the table for 1.938. So let's scroll down to the table. Okay. Now this table is slightly different than, or let's say it's more detailed than the one they have in the book. You can use that one or this one. That one a little bit easier, but this one is more detailed. So how we're going to use to find the t-value here, the t sub 0, t-value. Well, it's degrees of freedom is 11. So here this includes degrees of freedom. This is 11. So the value I'm looking for is going to be somewhere on this row. Somewhere on this row. Also, remember the t value or the t statistic was given as negative 1.938. Again, we said we can look at it as a positive because it's going to be the same. Now in that row, which one is the closest to 1.938? 1.9. Well, I see this one here and I see this one. So this means, this tells you the p-value is you have to go up to what? We are doing, there are two things here. There's one tail test or two tail test. One tail or two tail, but we're doing one tail test. So we're going to go across this row here. One tail test. And what do we have is something somewhere in between these here. That's what it is. So the p-value, these are the p-values, okay? These are the p-values. So the p-value is somewhere between 0.05 and 0.025, right? But actually this is smaller than the other one, so you need to swap them. Put the small one on the left side and the bigger one on the right side. Now we found the p-value. If they ask us, do we reject the null hypothesis if the level of significance 5%? Well, at 5%, so alpha is 0.05. Notice the p-value is between 0.025 and less than 0.5. Well, the p-value is less than alpha, so we reject the null hypothesis. If the test is a two-tail test, then we need to use this row here. We need to use that row where it says two-tail. In the table in the book, both of them are fine to use. Like it's only one row is listed for us, which is okay. It's not going to make a difference with the result. Now, what about if they give us two-tailed? Again, the same way. Like this is a two-tailed test, two-tailed t-test. They want the p-value. It's a matter of reading the table actually. So the size is 25, so the degrees of freedom is 25 minus 124. So you go to the table 4, the t table or table 4, and find this number, or its opposite, like the 0 point by symmetry 0.895. You will find out on that row in the textbook this number does not exist. But what we do instead, we pick the smallest number. So the smallest, or the in that row, is 1.318. 1.318. So if you look at that one in the table, 1.318, and you travel up vertically, you're gonna find it. This corresponds to t sub 0.10, 0.10. Okay, so the p-value, you can say 0.10, 0.10. Okay, and then hence the p-value, that's for just for the first half. So that's like for this half on the figure. Same thing on the other side. So so the p-value for the whole thing is 0.20. 0.20. Notice on the table, if you look in the table, what happens in table 4. Notice as the number increases, like as you move to the right side. So in row 24, when n is 24, and you move to the right side, the numbers increase from 1.318 to 1.7 something, 2 point something, 2.4, 2.7. So it's increasing. So this p-value that we got, the 0.20, that's the least, or you can say more than. The p-value will be more than 0.20, more than, because we expect to go to travel more to the left on the first row. That's why the p-value increases. So it's more than that. Okay, so that's more than that. Now, if alpha is given, let's say like 1% or 5% or 10%, still the p-value bigger than the alpha. And that's why we fail to reject the null hypothesis. We fail to reject the null hypothesis. Now let's look at this one here for the one, again, one mean z, the z-test. That should be the t-test, not the z-test. So we're gonna replace this z with t. To perform the hypothesis testing, we need to make sure it's a simple random sampling, normally distributed, or n bigger than or equal to 30. And the only difference here is that mu, the standard deviation for the population, is not known. And I'm sure everyone knows how to set up the hypotheses. So we use this one. This is the T statistic. This is the T statistic value. So if they give us, for example, let's say the mean is 21, sample standard deviation 9, sample size 32. You can tell it's bigger than 30, so it's normal distributed. And let's say they have the hypotheses, mu is 22, or mu 0, and mu less than 22. So H1 or HA, the same thing. That's the null hypothesis. We're gonna see how to find the T statistic first. The T statistic is x bar minus mu over s over square root of n. Just a direct substitution. 21 minus 22 over s is 9 over the square root of 32. And if we put this into the calculator, that gives us negative 0.63. Even if you get negative, that's okay. It doesn't mean it's anything wrong. Okay, it doesn't mean it's wrong. Now, if we need to find the critical value, okay, how do you find the critical value? Because here, what we do is the same thing as the z-test. Either we have the critical value approach or the p-value approach. And I showed you a little bit about the p-value. Now, how do we find the critical value? How do you find it? So here, what we need to do is to find the critical value. It has to be given, alpha has to be given. Let's say it is given that alpha is 5%. 5% level of confidence 0.05. This is given to us. And what we need to do is we need to find out the critical value using table 4. Okay, so how are we going to use table 4? You can look in the textbook, as I'm doing right now, and I'm looking at the degrees of freedom is n was 32, so we're going to look at degrees of freedom 31 horizontally, and then so you're going to look at this way, 31 here, and on the top you need to look at the t sub 0.05 because that's what alpha is, and down. This number is the one we're looking for. What is the value of this number here? This number that I see right now is 1.696. 1.696. But you have to watch carefully for this. When we are doing the t-test and it's left-tailed, we always find negative t sub alpha. So it would be negative. This is negative t sub alpha. Yeah, t sub alpha is this, but the negative, it should be included there. If you're doing only the right side, it would be t sub alpha. If you're doing two-tailed test, that would be plus or minus t sub alpha over 2. Very important to keep an eye on those tests or those procedures. So that gives me the critical t value, which is negative 1.696. Now to continue with this specific problem, we found the t sub 0 and we found the critical value. So if I interpret this on the graph, so let's say I'm gonna put it here. Okay, so this is the t distribution, t curve. So we found the critical value, negative 1.6 something, let's say negative 1.696, and it was a left tail test. Left tail test. Now we need to find out where is t sub 0, the test statistic value falls in. Well, it's t sub 0, we found it, negative 0.63, negative, it falls here, negative 0.63. Does it fall in the rejection region or not? No, this is the rejection region. So it doesn't fall in there, so we do not reject the null hypothesis. Okay, we do not reject the null hypothesis. If it is a right tail test, we do exactly the same way. We exactly approach it the same way. Nothing is different. It's kind of similar to the previous several sections. All follow the same procedure.